Hi, we are VoiceK and our project is an exploration on zk-Biometric authentication using voiceprints, analogous to fingerprints but with our voice. We got inspired by this tweet about using voice in a secure way and decided to start building our project on this. Since voice is the most reliable authentication method according to the Fundamentals of Biometric Technology book, why not use it as our most secure authentication method in a private or verifiable way? But all of authentication nowadays relies on centralized big servers. Should we trust them? Should we rely on centralized untrusted big tech? No, and that's why we started to investigate on private or verifiable ways to do it. And this is how we found zk-email. Our first approach was to use two main components, a voice laundry machine for the pre-processing and extracting of the voice features, and a time machine, a time series model, for the learning or inference on those features, made voiceprints. This is a demo on how the voice laundry component worked in practice. This is running in our local machines. We used Python since it's the most popular ML environment to use, and the Librosa library, which provided the necessary ML tools for this. In the video, we can see how we are recording 10 voice samples, and these are sent through the pre-processing logic, where we are managing to extract an MFCC vector. But we are seeing this currently right now. It's gonna take a few seconds.
Okay.
We are using one word specifically with different variations on tone, sound, so that we have different features extracted. We can see different wavelengths over there, the features in charts, and there's the matrix that we want, and some statistics on the features. But after trying this on a zk-VM, we failed. Turns out zk-VMs are still limited. We cannot process a large input here. Most libraries cannot be compiled for audio processing purposes. So we pivoted to a second approach, and in which this was just us trying to remove complexity and use ready-to-use models and datasets, with the end goal of being able to execute this and actually use the proofs of execution to verify the correct calculations. This approach consisted on using two different models, a voice identification model with RONet 3, in which we get the name of the person who spoke out of a giant database of voiceprints, and a second speech recognition model with the words spoken. Since we wanted to have a proof of what was said for, let's say, elevating permissions or proving that someone said something to authenticate, like a human proof. All of these will generate their own proofs with ezk-al. Then we will combine both of these outputs in a zk-VM, in our case using zk-MIPS. Here is a demo on the ML model, specifically RONet 3, running on Python. Here's just the setup. You can see the imports of the libraries and the setup of the model, and then extracting embeddings on the audio file, just processing the audio file, and we can run this from beginning to end, and it's gonna take some time to show up. So here's the error, which mentions that there's a limitation on ezk-al from this model. We cannot just use it because it has some if gates that are not currently available to set up on ezk-al. So some of suggestions over there are just modify the model or try to customize the exporting logic from the ezk-al to get this. And then yes, so This is another demo, this time with the voice activity detection models. We're just as a speech recognition, right? When speaking starts, when it ends, and which words are said. We have some different models here. We have Pyantate, we have Silvero, and then we have some of the most reliable ones, or the ones that got the features extracted as we wanted, which were Wave 2 Back 2 and Whisper. In this case, we can see that Wave 2 Back 2 outputs. Let's just wait for it to show. Yes, you can see that it outputs the words spoken and the start and the end time of when the word was spoken, so it's pretty specific on the timeline. And then there's WebRTC, which we didn't really use. We got an error over there. And then this Whisper Tiny, which also worked well. Yeah, you can see it's very similar to what WAV2 Vec2 extracted as outputs, so we could work with both of these models. And then again, we have the same error with the ECKL, which is during setup, right? And this time, one of the insights that we got was the kernel crashed, and the assumption is that we don't have enough random access memory in the environment for circuit generation. It requires more or less 700 gigabytes of RAM to circuitize this, so it's not possible yet. And so we hit some walls, right? We failed some experiments, but now we have some technical limitations outlined for implementing Voiceprint authentication using zk-email. On zk-VMs, we know now that these cannot process large amount data inputs. Most libraries cannot be compiled, again, using Python, let's say. Libraries on Python cannot be compiled. And this can only execute simple processing of short strings and basic computations. Then there are the machine learning model limitations. In this case, we have LSTM and RNN models that could require large training datasets. And ECK does not support tensor sequence operations. And also sound processing models cannot be circuitized. Then we have pipeline limitations. We cannot verify audio preprocessing in an end-to-end manner. We just found out about this right now. Voice feature extraction is too computationally intensive for current zk systems. This is a consequence of the last two being discussed. And then raw audio data processing is practically impossible with current technology because of all these other limitations, right? So in conclusion, current zk technology is not ready to handle the complexity of voice processing. While it is theoretically possible, and there's some research around this which are optimizing zk frameworks, zk-ML frameworks for deep learning. Right now, it's practically unfeasible with the current state of technology.